Good morning, students. Welcome to Bindu Dhadwal chemistry lessons. Our topic for today is preparation of amines. First method is from alkyl halides. So, by ammonolysis of alkyl halides, amines can be prepared. The reaction is also called Hofmann's ammonolysis method. So when an aqueous or alcoholic solution of ammonia is heated with alkyl or aryl halide at 373 Kelvin in a sealed tube, we first get an ammonium salt, which in presence of ammonia will give amine. Now, alkyl ammonium halide salt will give primary amine along with ammonium halide, and this primary amine can further act as a nucleophile on another alkyl halide molecule to prepare secondary amine, which will react with another alkyl halide to prepare a tertiary amine, which will react with another alkyl halide to form a quaternary ammonium salt. So in all these reactions, the amine, because of the presence of lone pair of electrons, acts as a nucleophile and seeks a positive charge center which is present on the carbon of the alkyl group of the halide ion. The process of cleavage of carbon-halogen bond because of amines is called Hofmann ammonolysis reaction. The order of reactivity of halides: alkyl iodide is more reactive than bromide, is more reactive than chloride. Benzyl halides also react with aqueous or alcoholic solution of ammonia to form benzyl amines. Second method, reduction of nitro compounds. So aliphatic and aromatic amines can be easily prepared by reduction of corresponding nitro compounds. Reduction can be done in a number of ways. We can use a mixture of hydrogen and Raney nickel, or hydrogen and platinum, or hydrogen and palladium at room temperature. The hydrogen produced by this combination reduces nitro compounds to amine. So similarly, nitroarene will get converted to aniline. Nitroethane will get converted to aminoethane. Nitrobenzene will get converted into aminobenzene or aniline. Nitro compounds can also be reduced with active metals such as iron, tin and zinc, and concentrated hydrochloric acid. The reaction with iron scrap and hydrochloric acid is preferred because the ferrous chloride formed gets hydrolyzed to release hydrochloric acid during the reaction. So only a very small amount of HCl acid is needed to initiate the reaction. The rest of HCl is produced during the reaction. So nitroethane on reaction with iron and HCl will produce nascent hydrogen, which reduces nitroethane to aminoethane. Similarly, nitrobenzene gets reduced to aniline. Nitro compounds can also be reduced to amines with lithium aluminium hydride. Nascent hydrogen produced by lithium aluminium hydride will reduce nitro compounds to amino compounds. However, with lithium aluminium hydride, aromatic amines will not be prepared because nitrobenzene with lithium aluminium hydride will form azobenzene rather than aniline. Reduction of nitriles. Nitriles can be reduced to corresponding amines using Raney nickel or platinum, lithium aluminium hydride, or sodium amalgam and ethyl alcohol. So when we reduce nitrile, ethane nitrile, with mixture of hydrogen nickel or lithium aluminium hydride or sodium amalgam and ethyl alcohol, this 4 hydrogens will reduce nitrile group. 2 hydrogen come to carbon, 2 hydrogen to nitrogen to form CH3, CH2, NH2. Similarly, benzonitrile will get reduced to benzyl amine. If this reduction reaction is done with sodium and alcohol, reduction of cyanide with sodium and alcohol, the reaction is called Mendius reaction. Similarly, This compound, benzyl cyanide, on reduction with lithium aluminum hydride, will form 2-phenyl ethanamine. The synthetic importance of this reaction is that the amine that is produced contains one carbon greater than the reacting alkyl halide. So if alkyl halide contains R carbon atoms, the amine that will be prepared will have one more carbon atom extra. Alkyl halide on reaction with alcoholic KCN will form alkyl cyanide, which on reduction will form amine with one carbon more. Similarly, reduction of isocyanides can be done with the same reagents. In this case, secondary amine will be produced. So, methyl isocyanide will produce dimethylamine, and phenyl isocyanide will produce N-methyl aniline. Reduction of amides. Amides can be reduced to corresponding amines by lithium aluminum hydride or sodium ethyl alcohol combination. So the hydrogen produced will be added here and here to form water and amine. So RCH2NH2 and water is prepared. If we reduce ethanamide, we get ethanamine. If we reduce benzamide, we get benzylamine. Secondary and tertiary amines can be prepared by reduction of secondary amide or reduction of tertiary amides. So N-methyl ethanamide on reduction will form N-methyl ethanamine. N-dimethyl ethanamide on reduction will produce N-dimethyl ethanamine or ethyl dimethyl amine. Hoffman bromamide degradation reaction. So when an amide is reacted with bromine in presence of alcoholic KOH, the amine with one carbon atom less is produced along with potassium carbonate, KBr and water. A very interesting way of learning the reactants in the process is, instead of Hoffman bromamide degradation, keep it in your mind, Hoffman bromamide degradation method. It tells a lot of information about the reaction. Hock, if you read KOH backwards, it is HOK. Hoffman bromamide. So three reactants are KOH, bromine and amide. And degradation means the amine that will be produced will have one carbon atom less than the amide that was taken. If we react benzamide with bromine and KOH, we get aniline, one carbon less, and KBr and potassium carbonate and water. Next method is Alkylthalamide synthesis. It is used for preparing only primary amines. So phthalimide on reaction with alcoholic KOH, H and OH combine to form water and K gets attached in place of H. So we get potassium, N potassium phthalimide. This is potassium phthalimide. When this is reacted with ethyl halide, the K and halogen, here in this case Br, will react to form KBr and C2H5 gets attached in place of K to get N-ethyl phthalimide. So this is N-ethyl phthalimide. On hydrolysis, these bonds will break, OH of water and H comes here and this breaks. Similarly, this breaks, OH of water and H comes here. So this is ethylamine. A primary amine is formed along with COH and COH with benzene. This is phthalic acid. So phthalic acid and primary amine are formed. So hydrolysis occurs on refluxing with NaOH or on heating with 20% HCl under pressure. Now phthalic acid can again be converted into phthalimide and can be used again and again in this reaction, and it will give pure amines. This is the advantage of the reaction. It may be noted that hydrolysis of an alkyl phthalimide is a slow process. So instead, if we heat it with hydrazine, N-ethylthalamide is, if heated with hydrazine in presence of ethanol, reaction will be fast and product primary amine will be obtained. Only alkyl primary amine will be produced. Aryl halide cannot be used to convert to aryl amine because aryl halide does not undergo nucleophilic substitution reaction with potassium thalamide. So aromatic primary amines will not be prepared by this method, only aliphatic primary amines. The next method is reduction of azides. So primary amines can be prepared from alkyl azides. We first convert alkyl halide into alkyl azide by reacting with sodium azide. So Na and X will combine to form NaX. And N3 gets attached here to form alkyl azide. This will be reduced with either sodium and alcohol or lithium aluminum hydride or hydrogen and pelletized carbon. So alkyl azide on reduction will form alkyl amine and nitrogen will be given off. So when C6H5CH2CH2X is treated with an azide ion, C6H5CH2CH2 azide is formed, halide ion is given off and C6H5CH2CH2 azide is formed, which on reduction will give off nitrogen and form C6H5CH2CH2 NH2, and amine with same number of carbon atoms as the halide. Next method is by reduction of oxime. So when we reduce oxime with lithium aluminum hydride or sodium ethyl alcohol, RCH2NH2 is formed along with water. The oxime is formed from aldehydes. CH3CHO plus NH2OH will form oxime. OH2 of hydroxylamine and O of acetaldehyde will combine to form water and oxime will be formed. This oxime on reduction will form amine. Ketoxime will form respective amine. Third is reductive amination of aldehydes and ketones. So aldehydes on treatment with the ammonia will form intermediate imine, RCH of aldehyde and NH of ammonia combine, and 2 hydrogens and 1 oxygen form water. So water is eliminated. So RCH double bond NH intermediate is formed, which is called imine. This on reduction will form, 1 bond will break, 1 hydrogen here, 1 hydrogen here, RCH2 NH2 to form primary amine. So acetaldehyde on heating with ammonia will form acetaldimine, which on reduction will form ethylamine. Similarly, acetone will form dimethylketene, which on reduction will form isopropyl amine. This reaction is formed by conversion of aldehyde or ketone to corresponding amine by reaction with ammonia and then reduction. So it is called reductive amination. This reaction is called reductive amination. It may be noted that instead of ammonia, we can also use amine. It will also act as a nucleophile. So 2 hydrogens of amine and oxygen will combine to form water, and this gets attached here, and then on reduction this will form a secondary amine. And if we reduce with a secondary amine, reduce a ketone with a secondary amine, we get a tertiary amine. So cyclohexyl ketone on reduction with dimethyl amine will form an N-dimethyl cyclohexyl amine, a tertiary amine. Next reaction is Scumage reaction. So carboxylic acids are treated with hydrozoic acid in presence of concentrated sulfuric acid. An amine with 1 carbon less is formed along with carbon dioxide and nitrogen. Similarly, benzoic acid will form aniline and carbon dioxide and nitrogen. Instead of hydrozoic acid and sulfuric acid, we can also use NaN3 and sodium azide and concentrated sulfuric acid. Industrial preparation of amines: pass the vapors of amines and alcohols over alumina at a temperature of 723 Kelvin to form amine. This, on further reaction with alcohol over alumina, will form secondary amine, and this will form tertiary amine. So mixture of amines are formed. This is industrial method of preparation. We can also prepare aniline industrially by reduction of nitrobenzene using either vanadium platinum catalyst with hydrogen at 680 Kelvin or iron HCl or tin HCl, and carry out its reduction to form aniline. Or on a large scale, we can prepare by heating chlorobenzene with ammonia in the presence of copper oxide at 473 Kelvin and 60 atmosphere pressure to form aniline. That is all in today's video. If you like the video, please do share and subscribe. Also practice these reactions. Thank you. Have a nice day.